So hello everyone, welcome to our channel. And as I promised that I will bring the 10 question series of every chapters. And so I come with today come with this physical spectroscopy chapter with 10 questions. It is very difficult to choose 10 questions of CSIR-NET examination, but I tried my best to bring. But if you want a second part of this, you can comment in the below that you want a second part of this, so I'll bring more questions from physical spectroscopy, as is the most important chapter in appearing in the CSR examination. Quantum chemistry last video, if you didn't watch this video, I put the link in the description box. You can see here, there also I solved 10 questions. And if you want more from quantum chemistry, you can comment as well. And if you want, if you like my videos, and if you want more videos according to you, means you want any chapters to be solved by me, or you want questions from any chapter, you can comment below. So I'll definitely try my best to bring videos for you before your CSR examination, because your examination is very near. I think in between 6 to 8 June it will occur. And this video will be very helpful for you, because it will help to memorize the concepts and the formulas of the all the chapters. So thank you for listening up to this, and I'll try my best to solve conceptually all the problems. And let's begin without wasting any time. Let's begin this video. And coming to our first question, I don't want to make these videos too long, because last video was too long, you didn't watch till the end. But try to just watch this, at least just watch till the end, so you can memorize all the formulas and concepts. So as you can see that for the first question is telling about that IR spectrum of CN whole 5H 3 minus, that is COH stretching frequency is observed as 1840 centimeter inverse. They are asking that COD means cobalt and deuterium stretching frequency in this. So the compounds are same, just change in the hydrogen. In place of hydrogen, deuterium the place, and they are saying that what will be the stretching frequency of the COD bond. So I think you all know the formulas of the from the IR spectroscopy, or for the stretching. When we are discussing about the bond strength or bond strength, so there is a formula, you know, that is the nu bar equal to 1 by 2 pi c root over k by mu. So it will talk about the our bond strength, and it is talk about the our bond strength, and it talks about our the reduced mass. So there is not that much difference in the bond strength, but there is a difference in the reduced mass. So we'll solve this problem according to reduced mass. So you know the reduced mass equal to, if the molecule is diatomic, so the reduced mass is m1 m2 by m1 plus m2. Okay, so so we can directly write this thing from here, that sorry, uh, you can directly write that nu bar varies 1 by root over of mu. So we can write from here that nu bar of COD by nu bar of COH equal to root over of inversely proportional, so mu of COH by mu of COD. So now we can write this uh, formula like COH. If we write COH, so M of CO into M of H by M of CO into m of d, okay, into m of CO plus m of mass of deuterium and mass of cobalt plus mass of hydrogen. Okay, so now we can see that there is here mass of cobalt will cancel, and you know all that mass of hydrogen is if 1 and mass of deuterium equal to 2. And let's say if you don't know the mass of cobalt, no problem, you can take as m, or I am telling that it is 59, but if you don't know, even it can solve this problem, because here you can see 1 by 2 means root over of mh by md, we can write 1 by 2 into, if you don't know the mass of the cobalt, you can write m plus 1 by m plus 2 by m plus 1. So it is nearly equals, yeah, so we can eliminate this. It is a approximation, means otherwise we can't solve, it will be very it will be very means complicated, the answer will not come. So for this for the matching with the options, so I didn't mention the options, but I already see that if we do like that, we are nearly equals to, but if we take the approximation, the answer will be correct, appropriate answer. So this will come. So they are asking about, you know that they are asking about the stretching frequency of COD, and we want this, so we'll put this there. So we can write that stretching frequency of COH bond by root 2. So as they told that the value of COH is stretching frequency is 1840 by 1.414. So the value will come nearly equals to, if you calculate with calculator will be given, so that is 13.05 centimeter inverse. So if you don't know the mass even, you can take approximation from there, that see, you can see there is we can take the approximation one. So you are saying that we can't, how we will take approximation. If you take 59 plus 1, sorry, plus 2 by 59 plus 1 means it is nearly 61 by 60, so it is nearly 1, you can take, that's why I took. If you don't know the mass, you can write m, as the difference is very less, only 1, so we can take approximation is 1 and we can solve, we can, so you can save the time and the value will come nearly. You can put the value as well, means if you know, but if you don't know, you can solve like that. Okay, so coming to the next question. Coming to the next question, that is the EPR spectrum of the tetragonal Cu2 complex is here, it is given, and they are asking that unpaired electron resides in which orbital. You know the tetragonal uh, so there is two chance possibilities of two orbitals, that is dx square minus y square or dz square. So here you have to remember this thing, that if you will see that G parallel is greater than G perpendicular, then the unpaired electron will be reside on the dx square minus y square, because it will be in the higher state. And if the G parallel is less than G perpendicular, it will be in dz, sorry, it will be in dz square, because then it will be in the higher section. So you have to remember this thing, you can take a short note from it. And one thing, I will share my short notes before 1 week or 10 days as a form of video, so you can see just before going to your bed, or if you are free we can watch the videos. So it will be very helpful for you to memorize all the concepts and formulas. If I will share my short notes in the form of videos. And already shared my experience, how I cleared my last JRF, means last June 2022, last year, how I cleared my JRF. So I shared already in the form of video. I'll put the link in the description, you can watch. Okay, so coming to the next question. Arey, so the next question is all about the vibrational levels, vibrational transition from 0 to 1. You can see that from here ground state to here, sorry, so from 0 to 1. Sorry about my bad drawing, but understand that it is 0 to 1, means what is it? It is a fundamental transition. I think you know the formula. If you don't know, I am writing the formulas. Like for fundamental, अरे यार, why fundamental transition, the delta E equal to omega E minus 1 minus 2 xc. Okay, and first overtone that is required in this question, they mentioned here. You can see that first see what is given. They already told the energy gap, means this one they already told, and the value of omega E and xc is given. The value of omega E we have to evaluate. The first overtone energy, first overtone we have to evaluate. So here delta E equal to omega E, here 2 minus 3 xc. I'll tell you how I can remember this thing. Second overtone, that is 3 omega E 1 minus 4 xc. So I took common from this from every 2 omega E. You can see here 1, 2 and 3. Here you can see 2, 3, 4. 1 1 increasing. Means I remembered this thing. It is not logical, but I remember like this. I put take common omega E from here, and you can see 1, 2, 3, 2, 3, 4. You can remember fundamental, first overtone, second overtone. Fundamental is here only. Okay, so you can remember like this, and hot band is one hot band, that is energy gap is equal to omega E 1 minus 4 xc. So now coming to the problem, that is our fundamental band, and the energy is given. The energy is given 2143. That is, we can write that 2143 equal to, we can multiply that omega E minus omega E x e 2. Okay, so here it is given, so we can put the values here. Omega E x e is 14, omega E minus 2 into 14, so omega E equal to 2143 plus 28. Yes or not? Okay, so the answer is array 2171. centimeter inverse. So this is the value of the omega E in centimeter inverse, and now they are asking about the first overtone. So we will put this value in the first overtone. So that is, you can see that here first overtone energy is that 2 into omega E minus 1 minus xe, that is we can multiply that 2 omega E minus 2 into 6 omega E xe, that is 2 into 2171 minus 6 into 14. So that will be 4 2 sorry uh, that will be 2 4 2 2 minus 84 14 overs 84 volts, okay, equal to 4 to sorry 4 here 4, sorry I am making mistakes, so many mistakes, 4258 4342 minus 84 equal to 4258 centimeter inverse. That is the energy of the first water. Okay, I think you understand this problem. Now coming to the next problem, that is our fourth problem. Read the question carefully. That is the vibrational energy levels is here. Okay, we come next question. Just wait. Sorry for that interruption, because I put the same question in the two slides. That is, now read the question. It is from Mohs spectra. That is, Mohs spectra of two iron complexes are shown below, and they may rise high spin Fe3, high spin Fe2, and low spin Fe3. So which are the which means you have to tell that which complex have that singlet, or which complex has doublet. Before that, I want to just tell you that Mohs spectra will show either singlet, Mohs spectra either show singlet or doublet. Singlet or sorry doublet. Sorry, I am not habituated with this pen tab, so it will take a little bit time. Please adjust. So for singlet, for which the electronic configuration is symmetrical, and here for a doublet for unsymmetrical. So we just have to look the electron configuration of the d orbitals of these complexes, three complexes, which are symmetrical or unsymmetrical. That will be our answer. So if the electronic configuration is unsymmetrical, then it will show doublet, and if it is symmetrical, that is show singlet. I'll make a separate video for Mohs spectroscopy, detailed video. So in that video you will come to know all the things. It is not depends on the electronic configuration, it depends on other things as well. So I will make some slides, and I will show you the Mohs spectra, how it's detected, how we will know all about Mohs spectra. So now focus on here, that is Fe3 high spin. Fe3 means what? Fe3 means D5. So tell me the configuration of the Fe3 plus high spin. That is, I know that for iron, it is 4s2 3d6, but we have 3 plus, so d5, 3d 5. High spin means all single, so it is, you can see, symmetrical, and so it will go to the singlet. It will give singlet. So next is high spin Fe2 plus and low spin Fe3 plus, I think. Yeah, high spin Fe2 plus, high spin. High spin means Fe2 plus means D6 system. Okay, 3d6, that is D6 system. So and high spin, so it will be like this. It is symmetrical or unsymmetrical? Unsymmetrical. So what will it provide? Doublet, because unsymmetrical. Unsymmetrical. Next what was that? I think low spin 3d6. Yeah, low spin 3d. Sorry, low spin Fe3. Low spin. So Fe3 means d5 system, but it says low spin. So two Eg electrons will come to T2G. So it will also unsymmetrical. So it will provide what? Doublet. Two peaks will come. So this will be the answer. I think you understand the whole things. Okay. So now coming to the next question. Read this question. That is omega e equal to 512 centimeter inverse and omega in xc is 8 centimeter inverse, where omega e is the energy associated with the natural frequency of vibration and xc is the harmonicity constant. They are asking about the dissociation energy of the molecule. So here you have to know. So here you have to know that what is the DE, dissociation constant, that is D. It has a formula. It's the formula is that omega E by 4xc. It is the dissociation constant. And there is another term, that is D. It is called the centrifugal distortion constant. Distortion constant, that is different. That is equal to 4 bq omega square, omega bar, sorry, nu bar square. So here this is the we have to calculate. Means I am telling these things because you have to relate everything with not only the question, but if you study like this, mean if you relate things with similar things or related things, if you study like that, your memorizing power will increase and you can relate the things in examination and in any situation. Okay. So dissociation energy equal to omega equal by 4x. So now we will put the values. We will put the values simply, and nothing is there in this problem. So DE equal to omega E is given here 512 centimeter inverse, and XC we have to calculate. Now we have a problem. No, nothing is problem. Omega EXE equal to 8 centimeter inverse. Now we know the Hc equal to 8 by omega E is equal to 512, and centimeter inverse cancel. So we will put this value in here, like 512 by 4 into 8 by into 512. So I already calculated this value. Means I don't want to waste time so much. You can calculate it. Please do with the get calculator. Download get calculator. Go to the Play Store of your mobile and download get calculator, and practice with this calculator every day, because then it will be smooth in your hand during your examination. And I will telling the simply things. If you are going any shop, you are calculating something, if you need calculator, please use this calculator. In every situation use this calculator, no other calculator use, because in every exam you will get, in every CBT exam, if calculator is applicable, they will provide you get calculator, so you have to practice this calculator. So the answer is the 8192. This is the question is about only memorizing the things. What is the value? Many of you don't know. Many of you know this formula. If you don't know, you can note this, and also this centrifugal constant also, and the dissociation energy as well. Okay. Coming to the next question. Coming to the next question. That is the vibrational frequency of the and the enharmonicity constant of the alkyl halide is 3. Okay, vibrational frequency, and that is omega e and xe. You have to look first the what is given in the in the problem, and what you have to find, means our what is our target, final target, and what is already given. So a image will be image will construct in your mind, and you can easily come to the problem if you can think. So we need the here we have to calculate the positions, sorry, the positions of the fundamental mode and the first overtone we have to calculate. Okay. So here simply positions of the fundamental mode means the at which means frequency it is coming in centimeter inverse, at which frequency the fundamental positions is coming. So nothing else. Here omega is given 300 centimeter inverse, xc is given 0.0025. So for fundamental frequency, you know already the fundamental frequency, you know already the formula, that is delta equal to omega e 1 minus 2 xe, that is omega e minus 2 into omega e xe. So we can put the value, uh, and we can put the value of first overtone, first overtone, that is delta epsilon equal to 2 omega e. I told you how to remember these things, I think you got it. Okay. So 2 omega e minus 6 omega e x e. So just we have to put the values and calculate, nothing is nothing is here, nothing more than that. Okay. So now omega e x e, what is the value? That is 300 into 0.0025. So 100 if we multiply 0.25 into 3, so it will come 1.5. Okay. So it will come 1.5. Huh? Sorry, it will come I'm doing so many mistakes today here. Sorry about the mistake. Here if we multiply 100 with this, we will get 0.25 into 3, that is 0.75. And here omega e is the 300 minus 2 into 0.75. Don't need calculator. 300 minus 1.5, that is 298.5 centimeter inverse. Samely we have to put here 2 into omega e means 600 minus 6 into 0.75. So This is also same. This is also same. If 0.75 into 2 equal to 1.5, 0.75 into 6 equal to 1 point, sorry, 4.5. We are multiplying with 3 of this. Okay, so 595.5 centimeter square. Okay, so this is the answer. This is the fundamental frequency, and this is the first overtone. That's it. Now coming to the next question. That is question number 7, I think. Please follow me until the end. You will be definitely you will get benefit from this video. Otherwise, it depends on you. To record the Mossberg spectrum of Fe containing samples, a source X is used. X after a nuclear transformation to Y, gamma gives radiation and used in Mossberg spectroscopy. So it is how Mossberg spectroscopy we use. That is the thing you have to know. So the main thing is that in Mossberg spectroscopy we use that 57 of cobalt. It after capturing an electron capture, it converts into the excited state of Fe. I am putting star because of excited state. Then it comes to ground state, that is Fe 26. So when it is coming to excited state from the excited state to the ground state, gamma radiation occurs. When a element, radioactive element, come to the ground state from its excited state, gamma radiation occurs in its initial excited state. And you know the cobalt, that is 27, after capturing an electron, that is K capture, it's a radioactive element. We use this element. After capturing one electron, it converts to 57 Fe of its excited state, and when it comes to its ground state to by emitting gamma radiation. As I told that I will definitely come with a video. I already making some slides related to Mossberg spectroscopy. I'll discuss whole Mossberg spectroscopy in that video. So now for this solving this problem, I just keep this topic smaller. So just remember things that we use 57 cobalt, that is radioactive. After electron capturing it, its convert into Fe, excited state of Fe. Then by releasing gamma radiation, it comes to ground state. Because 26 Fe is the stable molecule according to nuclear chemistry. Okay, because of n by p ratio and magic number, all the things we know, that we come to know. And the binding energy per nucleon, that from the curve, we all know that 26 Fe is the most stable element. When I will teach the nuclear chemistry, I will discuss why we called the Fe the stable. Okay, now we will focus this that in the question. On the question, what is the X after nuclear transformation Y, means what will happen. Okay, so the problem is that what is the X and Y respectively, means source is X, and after a nuclear transformation Y, gamma radiation used in Mossberg spectroscopy, and X and Y, what is that, means source is 57 Fe, sorry, 57 CO cobalt, that is the source. And after electron capturing, it is converting to excited state of Fe. Sorry, it is converting to excited state of Fe after electron capturing. So it is the X and it is the Y. Sorry, my health is not good, little bit. Okay. Now coming to the next question. So you can see that here, you can, I think you read this first question already. That is 1 H frequency is 1 Tesla. It is 42.4 megahertz, and gyromagnetic ratio of 1 H and 36 nanometer. Gyromagnetic ratio is represented by gamma. That is gamma of A is equal to 27 in 10 to the power 7, and gyromagnetic ratio of 13C. So you can see here 13C is written, not 12C, because 12C is not nuclear active, because its nuclear spin is 0. I of 12C equal to 0, because all the even and all the even if the even neutron and even proton is present, they will cancel with the nuclear spin each other, and the ultimate nuclear spin is I equal to 0. That's why it not 12C never show NMR. Net spin is 0. So 13C is 6.75 into 10 to the power 7. Here you can see the gyromagnetic ratio. So there is a formula, I think, that is 2 pi nu. Nu is the frequency, equal to gamma into H0. H0 is the applied magnetic field. External applied magnetic field is the, here is the precision. So the precision equal to gamma H0 by 2 pi. So you can see here we are using 1 Tesla, that is after external magnetic field, and what will be the frequency of the, means this precision, this frequency they are asking, this precision at 1T, means H0 is constant here. So you can see 13C at 1 Tesla, 1 more frequency is 1 Tesla. Then we have to calculate the frequency. So we can take this part is constant 2 pi, and here also constant. So we can make a relation like the frequency, is directly proportional to the gamma. See, this is the nu, this is the gamma. Nu is represented here, and gamma is, you can see here in torque like things. Okay. So nu of 13C by nu of 1H equal to gamma of 13C by gamma of 1H. Don't be confused of my handwriting. So gamma of 13C we have to calculate. Here gamma of 13C is given 6.75 into 10 to the power 7 by 27 into 10 to the power, 27 into 10 to the power 7 into frequency is given 42.4 megahertz. So this is in Tesla inverse, second inverse, it will cancel out each other. The units of so unit of the unit of it cancel with each other, so it will come in megahertz. So it will cancel. I already calculated this. It is coming like 10.6 megahertz. I didn't convert it into hertz. Let it be in megahertz. So the answer is coming in megahertz. So this is the answer. This is the simple it is the only I introduce this question because to remind you these formulas. If you forget these formulas, because sometimes you forget to study some formulas and some little things. So I think from this problem we can memorize this thing. Okay. So now coming to the next question. See here, you can see that the complex is given. One complex is there. Cu is present. It's I. The nuclear spin is given here, and it connected to a oxygen that is 16. Oh, that is not nuclear active, but nitrogen is present. That is nuclear NMR active. Hydrogen is NMR active. Carbon 13C is NMR active, not 12C. But they already mentioned here that NH protons does not alter the EPR spectrum. Okay, so they want to know the number of hyperfine lines expected in the EPR. So we all know the formula, that is 2ni plus 1 rule. Okay, and n is the equivalent nuclei and I is the nuclear spin, and you know that a nuclear spin of n equal to 1. Here they are saying that NH proton does not alter the EPR spectrum, so we will not take the NMR spectrum. So we will calculate the EPR lines by only nitrogen and copper, because the H protons are does not call, they already told that H proton does not alter the EPR lines. So it is n plus 1 into 2n, this is n Cu plus 1. If the hydrogens are included, we will write another 2ni plus 1, but it is not there, so we will not calculate that. So here 2 into number of nitrogens are present 2, nuclear spin is 1, sorry, plus 1, and copper 1, only one copper is present, the nuclear spin is 3 by 2 plus 1, so 2 to 4 5 into 4, so equal to 20. If the hydrogens are included, then we will multiply it another 2ni plus 1, that is 2 into 2 into half plus 1, that is 3. It will be give 60 lines, but now it is the answer is 20. Okay, I think you understand. Now coming to the next question. See, molecular spectroscopy is so much important in any exam, in GATE exam as well as uh, in NET examination. In TFR, all exams, molecular spectroscopy is really important in any MSc level exam. So you have to do these problems, and 10 questions are, I think, very less. It's very difficult to pick up. If you want, I can make another part of this video, so I'll come with another some important questions. Okay, so if you want, you can comment below. The rotational constant and the fundamental constant of HBr are respectively 10 centimeter inverse and 2000 centimeter inverse. So corresponding the dbr approximately means we already initially, I think, did one problem and in this video, that is cobalt hydrogen bond and cobalt deuterium bond. It depends on the that frequency, the rotational constant, we know that b. Okay, so there also we saw that here I think first tell me the formula of b, that is h by 8, sorry, by 8 pi square I c. This is the formula, and I means we can write here as well, 8 pi square mu r square c, I equal to mu r square. So B is inversely proportional to I, that is 1 by proportional to mu. So reduced mass here also coming. In that question also reduced mass, through reduced mass we understand the thing. So so definitely the rotational constant for dBr. So dBr is approximately, the reduced mass of dBr is twice of the approximately twice of the reduced mass of HBr. Okay, so definitely the B value will decrease here for dBr. B value will decrease in dBr. So how much it will be? So definitely the answer will be not A20, it will be 5, means this one or this one. And the thing is that fundamental constant is given 2000 centimeter inverse. No need of calculation I think, because we already know that the B value will reduce for dBr. So 2000 will not be the answer, and this one will be the answer. So this one is already eliminated. So this one, I already told you something that sometimes we have to eliminate the options so we can get the answers. But during practice, you are practicing in home, so you should not see the options first, because it will be means let your mind to think. It will increase your memory capacity and thinking ability of the problems. So sometimes I eliminated the options in questions you I think observed there, because if you see the options, your mind will go to directly to the option, and will you will work like option elimination. But during practice in home, you should practice without options, so it will increase your thinking ability. But now this problem is all about option elimination, that's why I put this problem. But during practice don't do that. But in exam, because we have to clear JRF, we have to do questions, sorry, answers. We want marks, so we will try shortcuts. But not during practice. Not during practice, remember this thing. We will do shortcuts to save our time and to be fast and tricky. So that's all. If you want more questions means related to this topic or other topic, you can comment below. I'll try to come with videos. Thank you everyone.